In this video, we will present RelationField. Relate anything in Radiance fields. We build RelationField on NERF, which recently has been extended by methods such as LERF or OpenNERF, which extend the NERF formulation by proposing an additional output feature that is supervised by a foundation model such as CLIP. Using LERF, we can query different textual labels encoded by CLIP to get localization outputs in the 2D rendered images or directly in 3D. Here, for instance, for simple objects such as the soap bottle or higher-level concepts such as the color yellow. Using LERF or OpenNERF, we can localize objects in simple scenarios very effectively. However, in real-world scenarios, there are often duplicates of the same object in a scene, and we need to use more complex queries to localize the desired object. Relationship descriptions are very useful in these situations. For example, we can distinguish between the backpacks in the scene by describing their relationship to the bed or the wall, using a query such as the backpack leaning against the bed. However, we observe that when using more complex queries, methods like OpenNERF often struggle to localize the object of interest, as they tend to confuse the target object with the additional information provided in the query. Therefore, in this work, our goal is to model 3D relationships explicitly within RadianceField methods for an improved understanding of complex queries. To this end, RelationField extends the NERF formulation by adding an extra language output feature, similar to LERF, that encodes object relationships. In addition, we introduce a secondary XYZ ray as input, which is used to condition the relationship output. The motivation behind this is that, unlike objects, which usually exist on their own, relationships always require a reference point that anchors the relationship to another object. For example, if we select the bottle as the reference, RelationField can be queried for different relationships such as standing on with respect to the bottle, and RelationField highlights the shelf that the bottle is placed on. Once RelationField is trained, any object in the scene can be chosen as a reference point, allowing us to explore a wide range of relationships, including compositional, comparative, spatial, affordance, and support relationships. To train RelationField, we follow standard NERF practices. We shoot rays into 3D space from our camera viewpoint, but in our method, each ray includes an additional XYZ coordinate, specifying the relationship query. The neural network outputs RGB values, density, object features, and relationship features for each sampled ray, which we then render onto the image plane for supervision. Depending on the size and complexity of the scene, we typically require between 50 to 200 images for supervision. We encode each image using a foundation model, here ChatGPT, in combination with an advanced visual prompting approach called set-of-mark prompting. This prompting overlays automatically generated masks and numbered tags on the image, making it easier for models like ChatGPT to reference objects and their relationships accurately. ChatGPT outputs textual captions describing these relationships along with the object tags. To enable open vocabulary queries that are not exclusively overlapping with these textual captions, we encode them into a high-dimensional space using a language encoder such as BERT. These encoded relationship features are placed within the corresponding masks, resulting in multiple relationship feature maps per image, each representing the relationship of one specific object pair. To efficiently supervise the NERF outputs, we employ a pair pixel sampler that selects relevant pixel pairs from the generated feature maps, corresponding to the camera array and the relationship query position. The training objective is a cosine similarity loss applied for feature distillation. But RelationField not only works on one particular scene type. Without needing to change the training pipeline at all, we can train RelationField on different scenes such as kitchens, bedrooms, bathrooms, and living rooms. Relationships can be extracted by interactively clicking objects of interest and querying their relationship. Or these clicks can be sampled automatically on the objects in the scene, together with a predefined set of relationships to be investigated. One powerful aspect of RelationField is its ability to understand functional relationships. For example, in this scene we select the light switch and query, the relationship turns on. RelationField successfully highlights the light in the scene. This kind of common-sense understanding of causal relationships can be very useful for a robot agent that is tasked to turn on the light and needs to know that it has to interact with the light switch rather than the light itself. When utilizing both object semantics and our novel relationship understanding within RelationField, we observe significant improvements in open vocabulary object localization for complex queries. For instance, given the complex query, the monitor standing on the desk, RelationField successfully identifies only the monitor as the object of interest, whereas OpenNERF highlights both the monitor and the desk. The advantage of explicitly reasoning about object relationships becomes even clearer in scenarios involving multiple identical objects. In the next example, there are two curtains, one hanging on the door and another in front of the windows. When queried with the curtain hanging on the door, OpenNERF incorrectly highlights both curtains and additionally the closet doors in the scene. In contrast, RelationField, which explicitly models the relationships between objects, correctly disregards these incorrect predictions and accurately localizes only the curtain hanging on the door. This improved localization capability is also supported quantitatively, with RelationField outperforming comparable NERF and 3DGS-based methods such as LERF, OpenNERF, and Langsplat in open vocabulary localization performance. To summarize, RelationField enables 3D relationship reasoning entirely trained from 2D observations. RelationField redefines inter-object relationships as ray pairs in the NERF formulation to capture the semantic interactions between objects. Finally, RelationField encodes powerful foundation model knowledge, making relationships between objects queryable in near real time. To find more information on RelationField, as well as code and demos, you can visit our website.